you off the stage. You have the ability to take 2 questions, no more than 2 questions at the end. So if you want to save time, you can do that, or you can use up the entire 5 minutes and take no questions. So with that, the first person we have up is Jerry Hilburn from Epsori Space Systems. Jerry? Not in the room. Okay. Then up next we have Tim Bandele, who I do see in the audience. If somebody could actually stick their head out in the hallway and see if they can find Jerry, that'd be cool. So, ladies and gentlemen, Tim Bandele.
Whoa, jeez. Yeah, well, my name's Timothy Bandele. About 15 months ago, 3 of my friends and I started a business called Frontier Astronautics, and so I'll just tell you a little bit about myself and the company. Used to work for Lockheed Martin as a propulsion engineer on Titan, the Titan program, and I was a principal engineer of the Titan II attitude control system. So, as you might expect, our 2 main products are rocket engines and attitude control systems. So we have contracted 2 companies now for attitude control systems, one being Mast in Space, going to be doing the attitude control system for their lunar lander centennial challenges here coming up in October. We also have a liquid oxygen kerosene engine that we're actively testing. We fired it. It's designed for 7,500 pounds of thrust. And also we're starting up production of hydrogen peroxide. We have a customer for that as well. So that should be available again to the private space industry. Last thing, a lot of you might know me. Also, my wife and I bought a Atlas E missile silo here a few months ago. So we have the facilities to machine a lot of components, as well as test the engines and fly your private spacecraft. It's out in the middle of nowhere, Chugwater, Wyoming. So you can test and fly, and we're leasing that facility to people that would like to enter the business. And that's pretty much it in a nutshell. So I'll probably take my 2 questions. Oh, frontierastronautics.com, one word.
Any questions? Anybody? Robin's got one.
Yeah, we plan to do that right now. We just moved in, so we still haven't put in the floors. We still haven't painted the walls. You have to realize that this facility was decommissioned in 1965, and so it was lived in, so it's in pretty good mechanical maintenance, but it could use a new coat of paint. So we're trying to refurb it, and then we plan to do that on a regular basis. Right now we're subcontractors. We have our ideas on how to build launch vehicles or what would be a good way to go about things. We're not millionaires, however, so we have to make a buck at it. And so what we plan to do is bootstrap. We have some valuable technical expertise that is not really available outside of the big companies. And so right now we're a subcontractor, and we're selling those systems to other companies. Great.
Next up, we have Derek.
Howdy, everybody. Hope we're all hanging in there. I'm Derek Shannon, and I'm happy to speak on behalf of a very interesting venture I've become involved with, actually, through my space contacts at the Space Frontier Foundation and elsewhere. The company is Lawrenceville Physics, and it's a small New Jersey technology corporation working with partners at George Mason University, the Naval Research Laboratory, and now the Chilean Commission on Nuclear Energy to develop very high-value applications of a device called the Dense Plasma Focus. I won't get too technical, but you can sort of illustrate our approach to what we're working on in a similar way to comparing the space shuttle to spaceship one. In the same way, the Maine Department of Energy program, the tokamak, or ITER, that's now going to be built in France for about 10 billion, 10 years, big numbers all around. That's sort of the space shuttle in our field. And we're the Spaceship One, and so our dense plasma focus is probably going to achieve much better results than what ITER is going to get much sooner at much lower cost. So to give you some idea of why you should care as a space, our initial investigations funded through JPL had specs for our space applications of a specific impulse of about 1 million seconds, pretty darn good, and specific power of about 500 kilowatts per kilogram. So if we are successful at the technical side, this will drive the further commercialization of space with results like 6-month transit time to Jupiter with 2-to-1 total payload to 2-to-1 total mass to payload ratio. All right, and some of the recent highlights: February 28th, Lawrenceville, with the support of our IP Council, filed our patent method and apparatus for producing X-rays, ion beams, and nuclear fusion energy. That's now pending. On March 2nd, our legislator in New Jersey in the State Assembly introduced legislation that would officially classify us as renewable energy. More technical discussion on what that is, but I can get into that with anyone. And on March 10th, we signed our agreement with the Chilean Commission on Nuclear Energy. Our previous experiments were with smaller dense plasma-focused devices. The Chilean device was originally from Dusseldorf, Germany, and is large enough to get a break-even fusion result in 2 to 3 years. So that lowered our costs from about $2 million to just $700,000 remaining. And so we're talking to angel groups and corporate sponsors, and we'll be together very shortly. So always happy to get any referrals for that nature. More recently in May, the chair of the New Jersey Assembly Environment Committee signed on our renewable energy legislation. And in June, now that our patent has been filed, we submitted for peer review a publication that will go into a greater detail about our approach and hopefully be published in a major academic journal. So, to give you an idea, finally, how am I doing on time?
You got a minute.
Okay, should I leave it for questions? All right, well, okay, this is good. So, an early review of our approach by 2 physicists at National Institute of Standards and Technology and 1 at the Department of Energy concluded, technically, the plan is very strong. The objective is truly revolutionary, yet the plan to achieve it is feasible. The steps to the objective are clearly defined. It's based on new, highly original theory and analysis, and basically they really liked it. So our final product, which we would hope to be available for licensing in about 5 years, in the event of continued technical success, would be about a 5-megawatt generator with a manufacturing cost estimated, we can pretty much source all the components now, about $300,000. So that works out to about $60 a kilowatt for an installation cost. And we heard, or about 6 cents per watt. And we heard yesterday talk about space solar power, more like $1 to $5 per watt. So that's not really going to create developing world energy poverty, and it's not going to really make us a freer society with more freely available energy. So this is the warp drive. It's very cool. I encourage you to talk to me and get an executive summary and just follow up and just stay tuned because this is a very cool project. And either way, we're going to do some new science and get some interesting results. Thanks. Oh, website. There's both a nonprofit, focusfusion.org website, Dense Plasma Focus Fusion, so we shorten that to focusfusion.org. And then the company's name up there, Lawrenceville Plasma Physics, just add .com. And you can get additional info on the executive summary if you just talk to me after. I'll be leaving at about 7 this evening, so don't hold off till tomorrow. Thanks.
Thank you. And next up is, where's Sam? There he is. And I would like to thank Sam for having the Star Trek episodes back in the back corner to watch.
Can people produce and distribute TV shows that cost hundreds of thousands of dollars? Oh, YouTube, video, and BitTorrent are letting anyone produce movies and distribute them, and we're seeing a profusion of millions of fan-produced videos. Can the same thing happen with nonfiction space shows or nonfiction launches? Space travel will happen one day, with or without Space Shot. It will happen with or without any or all of the announced rocket manufacturers and operators. The drive of humans to explore, to seek out and conquer the unknown is too powerful to ever be stopped. Where one fails, another will succeed. Space Shot is not about doing something no one else would do, could do, or will do. We're about propelling the space industry forward, about making space travel accessible to everyone. Innovation and technology advances faster, more efficiently, and becomes more reliable as more people gain access. The space industry will move forward, and our goal is to help push it along. Imagine with me for a moment if Henry Ford had given away hundreds of Model T cars a year using a skill game. More cars on the road leads to more gas stations and roadside businesses, more tires, oil, parts, and mechanics helping bring down the cost of owning a car. Imagine if Philo Farnsworth handed out tens of thousands of TVs to winners of sweepstakes. More TVs leads to more viewers, more shows, more ads, and more profit overall. So bring down the cost of individual TVs while sparking innovation as demand spurs competition. Space industry is no different. As soon as we can start making space travel affordable, making it possible for the general public, the sooner we will see moon trips affordable and possible, the sooner we will see Mars trips, the sooner we will see humankind exploring the universe aboard a spaceship. Space Shot will bring new people to use your products, who otherwise would be sitting in the back watching from afar, wanting to help but having no means to do so. Space Shot allows people of ordinary means to contribute to the industry. It allows them to build more revenue for space companies and participate in the excitement. Space Shot is an online skill game that has the potential to award any space prize. Companies have an opportunity to create additional profits through a market demographic they would not have otherwise been able to look at. Space Shot has the potential to build millions revenue, be the first to bring space travel to people of any and all classes. I hope you take with you the dream of getting behind amongst the stars, and Space Shot will help you make this happen. Questions? Skill games. Thank you.
And next up, we have Manny Pimenta with Lunar Explorer.
Thank you, Michael, and good evening, everybody. It's always a pleasure to address this group. This is, I think, the third time that I come here to talk about Lunar Explorer. We have just completed creating the world's first and best simulation, virtual reality simulation of the moon with surface level detail texture. It basically allows you to put the moon into your computer and go explore at your will. You can go anywhere that you want. You can visit the Apollo landing sites, the unmanned surveyor sites, and the Russian Luna missions. All the successful landing missions are simulated. All the objects are placed where they should be. We are about to go to market in about a month or so. You should be able to buy our software through the internet. It'll run on a regular desktop computer or laptop. All you need is a halfway decent video card with 64 megabytes of video or better. And our partners in this project is a company by the name of Virtual Arts, who have developed a radical new software development architecture that makes it possible for us to run a simulation sophisticated on a laptop or a regular desktop computer. And we have many other things in the works. This is the first level product, which is we feel sufficient to be marketable or commercially successful. But our expectation is to continually develop it and increase the level of realism and the level of detail and completeness until the model that we have is exactly an exact replica of the moon, according to the best information available. We've been involved in various activities related to this project. We're part of the SimSpace group, SimSpace work group, and we took part in a 3-day workshop at NASA Ames where our technology and our product was one of the featured presenters. We're also invited to participate in the table that preceded this event at this hotel. And I wanted to thank Mr. Dallas Bienhoff and Dr. Paul Eckert for that. A lot of the things that were talked about in the session were part of the information session. And at some point, a slide was put up, a PowerPoint slide was put up that talked about what we should do as far as creating interesting media, getting the message out to the public. And we feel half of the bullet items in that slide we have already done, and the other half are in our plans to do and to complete within possibly the next year. The next thing that we're working on was we're developing lunar rover races as a more engaging gaming element to get kids involved and interested in the moon. And there are a range of different designs for lunar rovers that can be raced on the surface, the real lunar surface, using 1/6 gravity. And we're preparing this for the AIAA conference coming up in September in San Diego, I believe. So the project, this phase of the project is pretty much complete. The reason for my coming here and talking to you about it is to let you know that it's complete, that you can soon go on the internet and buy it. By the way, one of the marketing channels we'll be using is space.com. We did a presentation for them, and they loved what they saw, and they decided that they wanted to help us market this product. The other reason that I'm here to talk to you about is because a lot of you have business plans or ideas for developing either vehicles for the moon or some sort of equipment that will be used on the lunar surface. And I just like to suggest that our lunar simulation is the perfect backdrop for showcasing and marketing your product. And if you're working on anything like that, I'd love to talk to you about the possibilities for doing that. Thank you very much, and I'll take a couple of questions if you have any. Yes, sir. Tell me again the URL for your site. Anything else in terms of, are you giving out demos or other marketing things that you do? Yes, we have just acquired LunarExplorer.com. We used to have lunar-explorer.com, and we were able to acquire LunarExplorer.com without the hyphen. So we like that very much because that's the name of our company and the name of the product as well, so there should be no confusion. As far as demos, we are in beta right now, and we have some beta test copies that we can hand out in limited numbers. We also have some videos, early demo videos of these lunar rover races that I could share with you. I'd be happy to share with you. Yes, sir. Sean, is it? Yeah. Did you say you could use a virtual reality headset? Exactly. 5 minutes isn't a lot of time to get everything in. This will run on a regular computer or desktop or laptop PC like I talked about, but it's built from the outset, from the very beginning, as a full immersive virtual reality environment where you can use a headset display with 3D stereo simultaneous displays and a head position tracking sensor where you can look in any direction and the computer will pan or tilt the image, so you get the illusion that you're fully immersed in the environment. One figure of merit that distinguishes our system from other similar systems is we can drive high-definition displays at 120 frames a second. That's 60 frames a second per eye. And that virtually eliminates all the latency times that plagued previous virtual reality systems that caused a lot of VOR, vestibular ocular reflex problems that caused nausea and so on to people that used these systems. That's gone. Our people have been on our system for almost half an hour and they've suffered none of that. So that's another marketing area that we're pursuing is we're talking to various museums and science centers around the country to set up more elaborate, higher-end display exhibits that people would not be able to get in their homes and create those museums experiences around the country as well. Thank you again.
And next up we have Al Differ from General Orbital. You guys actually heard their business pitch earlier in the week and figured I'd give them another 5 minutes. So come on up.
Hi there. My name's Al Differ. I'm with General Orbital Corporation. Our team was competing earlier for the business plan competition, and I think some of them are still. David is here. Jeff, our CEO, had to go home. There's me. Ed was here. And we've got some folks that couldn't make it here, Cedric and Herb and some other folks that I'm probably not remembering. What we actually do is build airships and airship rocket hybrids. That's the plan. Okay. In the realistic sense, we're also got bootstrap method. We'd like our rocket type airships to go into orbit, but you bootstrap your way to it instead of asking people for a big pile of money. So we're going to put the airships up first, and the business that we intend to be in is the provider of communications and observation type services. So imagine what you could have done with an airship hanging over New Orleans after Katrina if you had a few cell units sticking off of it. You begin to get the idea if you think about that. If all that works, then we intend to complete all the R&D to do the full-blown spaceship, something to fly people into orbit. That particular vehicle should be a very comfortable vehicle for flying passengers. I remember watching the Spaceship One footage, pilot having to hyperventilate to deal with 5 or 6 Gs or whatever he had to suffer through. And I just can't imagine little old ladies and children and stuff like that dealing with 5 or 6 Gs. 2, maybe. So we have to have another way, which is basically build a big spaceship, big inflatable object, and decelerate over a much longer duration. Much higher altitude is where you start. I'm going to finish up here, actually real simple, and give some credit to people who deserve it. I'm not going to rename all my current teammates. Instead, I'm going to work with them and try to help make them rich. The other folks here, though, deserve quite a bit of credit, and so I'll name them instead. One of them is John Powell at JP Aerospace. If you do not know how bright he is and how creative he is, then you should look in on what he does. He has done an awful lot to create many, many ideas and push them forward and get people inspired. I worked with him for 10 years. The team works very, very well. There's some other folks that you may not know as well. One of them is Matt Maniscalco. He used to be with JP Aerospace back when we were first trying to build our ships. He was a tireless worker. I saw the time cards. He used to put in 20-hour days and still come back the next day, and somehow had the energy to keep going. A couple more. David Brock used to be with JP Aerospace as well. Invented some of the ideas. Tireless worker, would create things, work out on the desert, help fly things, good all around. his father, Norm Brock. Norm actually worked on the Apollo program himself and came back out of retirement to help us build airships and spaceships and basically be the engineer that he was when he was working on the Apollo effort. Another one is Randy Stewart, a little older team member. Guy just walked in off the street, met us, looked at what we were doing. This is great stuff. And he was another guy who could do 20-hour days and still come back the next day and have the energy to keep going. And finally, I'll stop with Natalie Vollrath. She's an advocate of this organization. Her contribution is hard to pin down, but I can tell you we would have gone bankrupt at least 3 times without her. So you got to have people like that. Okay, these people deserve a lot of credit, and remember that when we try to keep pushing this forward. Thanks. Any questions? We have time for one question. Okay.
What is your relationship with JP Aerospace?
I am a former member. We split up about a year and a half ago, and I worked for 10 years. What I used to do was be the math guy. I have a physics degree, so there's not much math that'll scare me off. I used to fake it as an engineer when I had to, and basically help keep some of the other volunteers inspired. I am not doing that anymore, going off in a new direction with General Orbital. So our relationship is pretty much nothing. It's the past. Okay?
Sorry, and finally, we have James Grady from the Space Portal for Enterprise and Commerce.
Hello, I'm Jim Grady from the NASA Ames Space Portal. There's an office at NASA Ames in the Silicon Valley area of California. Bruce Pittman, who many of you know, is one of our more eloquent spokespersons there at the Space Portal. He wanted to give this talk. I wanted him to give this talk, but he had to catch a plane, so I'll try to stand in for him. Other people at the Space Portal include Dan Rasky of Reentry and TPS fame. Some of you know him. Also Lynn Harper and Gary Schmidt of the in the biotech area. Mark Newfield, who many of you have been working with already, and several student interns, and a few other folks. The Space Portal, as quoted in spacerep.com, the new Space Portal activity will create innovative opportunities in NASA commercialization and foster relationships with industry, particularly the entrepreneurial space industry. Our goal is to support our new boss, General Pete Worden, in the area of entrepreneurial space industry, and provide more of a Silicon Valley atmosphere for the new space economy. The speaker this morning, Stuart Witt of Mojave, several times mentioned trying to create a Silicon Valley atmosphere in the Mojave area, and that's what we're trying to do also at Ames. We are in the Silicon Valley, so those of us who do not know how to operate in a Silicon Valley manner, we just ask our neighbors who work for Google, who work for Yahoo or Apple or Genentech, and who are usually much wealthier than we are, and they will tell us how to work in a Silicon Valley manner. Also, there's kind of more of an international event for our activities, as our neighbors tell us, who are attuned to kind of a Silicon Valley way of operating, go global or go broke. We're looking at innovative ways of operating internationally. One of these may be the use of international offsets for for commercial space activities. Later on this year, in the September timeframe, there is a major space conference now for the first time actually in the Silicon Valley area. There's Space 2006. Pete Warden, our boss, will be a host there, and the theme of the conference, in keeping with this Silicon Valley theme, is space, the value proposition, and there are 2 new tracks for that conference, in addition to the usual tracks of like system engineering and space transportation. There is a track called Applications, Commerce, and Benefits by Lynn Harper, and which will include the various areas of new space economy, such as space tourism, space mining, space power, and a track that I'm chairing called New Space Partnerships. We'll try to combine the traditional and the newer entrepreneurial space community. For example, Lockheed Martin and Boeing, and then also with Elon Musk of SpaceX. Also, people like Rex Gevinen of NASA and Gary Payton of the DoD will be there, and both of these folks I've worked with in previous lives. One of the advantages of being my age, you typically have worked with most everybody in the space industry. So we look forward to any of you who are thinking about coming to enjoy the conference. Also, keep in mind the timing of it is late September, which is very timely for the Northern California wine harvest. So that's it. Any questions? Good. I'll yield the balance of my time to Joe Carroll.
Up next, yeah. Up next we have Joe Carroll with Tether Applications. He's not on the list, but if we had time, we were going to have him come up. So come on up, Joe.
Thank you. Again, my name is Joe Carroll. The company is Tether Applications, Inc. It's a California Schedule C corporation. It was formed as a sole proprietorship in 1990 and became a corporation in 2000 with our first commercial job. I've had 4 successful orbital tether experiments, lowering my sights by a factor of 100 from 200 miles to 2 miles. I'd like to sell a concept, a specific technology. I'm interested in talking with both potential customers and potential investors. It's a bite-sized investment that could make a difference in the cost of reusable or partly reusable launch vehicles of small or medium size. The technology is mid-air recovery of spent stages and payloads. Recovery techniques were developed in the 1950s as part of the development of spy satellite technology. The allowable costs, risks, cumbersomeness, and all other parameters were high, and the results showed that. That technique was used for 30 years. Over 500 capsules, or about 500 capsules, were recovered from space. The technology limitations were fairly severe. There was 1 person killed during 1 capture. The largest payload ever recovered is of order a ton. Okay, the snatch loads are high. The parachute was usually seriously damaged. I started thinking about this about the time the technique was put to bed in the mid-'80s. Came up with concepts that were documented in a LightSat conference paper that was in the DARPA LightSat conference in '87. I did a little bit of development work in it in the mid-'90s, culminating in a flight test of a mid-air capture of 1 parachutist by another. The top parachutist collapsed the chute of the other guy, let go several seconds later. The chute reinflated and flew normally. This allows one to capture an object, go to higher altitude with a helicopter or fixed-wing plane, let go, and play cat and mouse all day, and do a lot more training, a lot more cost-effectively than any other technique. Since the work that we and I have flight test videos if anyone would like to see those. I don't have them with me. There are techniques that can reduce the weight of the chute, the snatch loads, the probability of damage of the capture aircraft, and increase the allowable payload that can be captured by up to of order 10 tons. Okay? Now this is a scale of effort that is of order that of an SBIR, you know, $500,000 to $1 million. I don't know the exact amount. But I don't think that's the best niche to propose the development of it, because from the time you talk somebody into putting a topic in a federal program, write a proposal, get accepted, get phase one, take a chance on getting the phase one, phase two, it's 4 years. And that's if you're lucky at every step of the way. Going with commercial funding, there's the possibility of doing it in about a year to a year and a half, somewhat significantly cheaper, and with the possibility of having something that could be salable to the launch vehicle companies. Now, I'm interested in talking with either potential users or potential investors, and I'll be here. So just come talk with me.
Take some questions.
Questions? Again, it's mid-air capture by either helicopter or fixed-wing aircraft of a heavy payload with a gliding parachute. Yes?
Okay, are you familiar with the ice cream cone parachute that was used?
Excuse me?
Are you familiar with the ice cream cone parachute that was used?
The ice cream cone? I know.
It was shaped like the usual parachute, but then it had...
Oh, yes, yes, yes. And the mid-air recovery techniques are documented in the recovery systems design guide and all the variations on that in the last 30 years. And I've talked with the folks that have been involved in the history. I've talked with the people that are in the aircraft. And I actually develop the more refined version. It was planned for use in Genesis and would have been used if the parachute had opened. Okay, there was a mistake in installing the G sensor that was to trigger the chute. So I've been involved in a lot of the prior techniques, and I've been interested in this for 20 years, but was never able to justify work on it except when I had a little bit of funding as part of another project. Now I think that because of the new space interest in COTS and commercial tourism, et cetera, this is not something suitable for a CEV or first stage, you know, single stick 100-ton object, but it's suitable for objects up to of order 10 tons. I mean, I think that the snatch loads can be kept low enough that you should be able to capture about 2/3 of the rated single hook external carrying capacity of a helicopter. The largest U.S. helicopter rated load is either 32 or 36,000 pounds, depending on what part of the literature you read. The largest one is 44,000 pounds. So divide that by roughly 1.5, and that's what you could capture midair. The real advantage of mid-air recovery over land recovery is no weight of wings and wheels or dependence on finding a runway. And over water recovery is no damage due to impact or saltwater intrusion. Excuse me?
You have 10 seconds.
Okay. Any other question? You just come talk to me. Okay.
And finally, and this is the last one, I had one come up to me, this is Dennis Whipple talking about his company live streaming, and it's a internet streaming application.
Thanks. This won't take too long, but Ted, we're both doing the video taping, and Ted wanted to let you know about his website for the tapes.
Yeah, not so much the website, but I just want to let everybody know that we do have pretty much everything that's been recorded up to this point available in the vending hall right outside these doors. They're basically $15 a piece or $100. If anybody's interested, just come see me. Thanks. Yeah, I'll be here until probably 6 o'clock tomorrow.
I wanted to get up at this time because following the media presentation, there is a new technology, and Sam was mentioning about the internet, how you can put videos on the internet. There's also a company that, believe it or not, is located right here in Las Vegas. They're called VM Direct. It stands for Video Mail Direct, meaning they can live stream straight off the email the video footage. So you don't have to type all your emails. You can still type, but you can send video emails. But I think the exciting thing for especially space conferences, because I've been taping them and now lately, the last 2 or 3 years, helping Ted. For the last 10 years, I've been doing this, is that we can now live stream the event. I did a little sample this afternoon, but I'm on a cell phone connection, and maybe tomorrow a longer cable so we can get a DSL connection, because Jim Spellman checked it for me, and the graphics came up, but the signal I don't think was strong enough. It was flashing on and off. But we're going to do like a little beta test tomorrow and try to live stream it. And you can get this tomorrow from me, but the website will be livestreaming.cc. If those in the back wanted to test it out for us, we'd really appreciate it. So if we can get a DSL, internet Ethernet cable that long, I think it can go down to electronics. I would like to do that for you. But the future of this is really exciting because everybody can have their own broadcast station, and we can take over the media that is giving us a hard time with our message. And it's very inexpensive, and you can either broadcast or send video emails or say clips of a rocket launch you want somebody new to watch. You can embed it right in your video email and send it out to thousands of people. So it's got a lot of potential for the space movement, and see me afterwards if you have to. I guess is there time for questions? I was the last one, so we won't be long. It's the screen is on now. I'm getting the feed, from Ted's video source there, if anybody wanted to take a look at it later. So anyway, thanks a lot. Appreciate it.
And that's it for this year's live dating, speed dating. So live dating. So I think we're done for the day. So unless after this, and unless somebody from the conference organizers tells me otherwise, we're done for the day. Yeah, there's dinner and stuff, but I'm not in charge of schedule. So. After last night, I'm in charge of anything.